Hi everyone, my name is Hamza Sami and I am Senior Machine Learning Engineer at Premise AI. Today I am excited to introduce you Nexus, a lightweight framework, multi-agent framework for complex AI task automation. We recently launched our paper as well. It is also available on the archive. So in this paper we discuss the in-depth detail of the architecture, backbone of the framework Nexus, some of the benchmarking results, and some real world use cases as well. Today I will also showcase you a real world example which also mentioned in the paper case study as well. So in this example we will define a supervisor and we will attach a EDA agent to it. EDA agent will have access to terminal which we'll have installed in Vivado 2020. So EDA agent can have access to the Vivado CLI terminal. It can run the experiment, it can define the TCL command, it can define the Verilog design, it can define the constraints as well. So user will give the query as well as the RTL design to the supervisor, and it will define like I want to optimize this design for 300 megahertz. Supervisor will understand these requirements and it will also read the RTL design, and it will give the comprehensive TCL commands and the constraint to EDN agent. EDN agent will follow the instruction and perform the action and the experiments, and at the end of the experiment it will compile some of the details like what are the utilization of the LUTs, flip-flops, and what is the power results, and are the timing constraints, what are the negative slacks, and each and everything critical path. It will you can say create a comprehensive detail and give it back to the supervisor will see the results and reiterate the TCL commands and the constraints and give it back to the EDA agent. This loop will continue until unless we will have the optimized design according to the user requirement. So we will now jump towards the uh, chatbot, and we will interact with the chatbot to showcase and test the real world example. Okay, great. Let's start. On the screen, you can see two windows, the web app interface where I will interact with Nexus, and a terminal window. This terminal is shown purely for the demonstration purposes, just to illustrate how our EDA agent interacts directly with the Vivado CLI, although you would not normally see these behind the actions. Okay, I will be begin by creating a new window, project. Okay, hey Nexus, please create a project at, I would like to create it at home, Hamza desktop, and I would like to name it processor. I will use the RTX 7 board, which part number I will just paste it here. Great, let's run it. Okay, as you can see on the terminal, our project has been created and you can just review its structure. We can just see the message which we got from the Nexus. So it gives us the project path and project name and the part number and some of the structure details. Okay, next I received a design request from our design team. Since I am not a hardware engineer, so I will just use this provided code. So let me just paste it here. So I need you to run this design on 200 megahertz, and I will just paste the code here. Okay, let's run it. You will notice the constraints and the article commands are updated according to the RTL code on the terminal. So our EDA agent is setting these things on the Vivado project side using a Vivado CLI. Once these settings are set, it will just run the experiment. I will fast forward the experiment just to save some time. Okay, the experiment has been run, so let's see the results. So it ran the project on 200 megahertz and we got negative slack. It's around -1 nanosecond. Let's see the instructions which Nexus give to the ED agent. So it give create the project, ask to optimize and place a router design, and ED agent followed it, and we got the summary of using these settings. Hmm. I see there is a negative slack, so let's fix it. Okay, let's try it. I see there is a negative slack in our timing report. Please run optimization on timing closure, and maybe we can trade off on power and area to just achieve our goals. Let's write it and run the experiment again. So our project next step of the iteration is started. So ED agent updated the commands, it reran the experiment. Let me just fast forward it again. Okay, we got the results. Let me see the timing constraint. Okay, cool. We now achieved our timing goals. Great. Let's see the other results as well. The power is unchanged. And just quickly see what commands Nexus give to the ED agent. Okay, it applied some directives. It applies some aggressive optimization commands. And let's see the final report which ED agent give us. So we got some positive slack with no total negative slack. And we can also double check it from the Vivado project as well. We can just see how what is the timing results we got from the Vivado, which is the unclean version. Let me just get the result here. Okay, get, I think it is in the runs folder, processor.runs that implementation, and the file name was design timing report. Just open it. Okay, so it is quite a lot of text. Just grab the thing which you want to see. Okay, let's go to the Slack part. Mm, okay, there is the final Slack. There is it is. So we got 0.242 final Slack, which is the same, which is the EDA agent, and our Nexus is reporting. So cool. Through this demonstration, you can see how our Nexus and its EDA agent manages even complex design tasks. This makes it easier for everyone, even non-hardware engineers, to optimize design efficiently. Thank you for watching this demo. See you later.